So Alan Craig is, many of you on the call are familiar with the novel and innovative projects area of extended collaborative support that's led by Sergio Sanielewicz. And what this area is looking at is new uses for supercomputing, and one of these areas is digital humanities. So there's an increasing amount of digitized text and applicability to computing that from domains that previously have had very little intersection with computing. So recognizing that in ECSS we didn't really have the expertise to go after some of these new areas, we've undertaken some contract hires to bring in experts. And so Alan Craig is our first one of these experts in digital humanities. Alan's had a long career at NCSA, and we're happy to have him advising us and also all XSEDE users in this capacity. So Alan's going to talk about some of the projects that he's been involved with recently. So this, especially for campus champions on the call, this will give you an opportunity to think about how this expertise might be able to benefit others at your campus. Go ahead, Alan.
Great, thanks. Hi, everyone. I thought, first of all, I'd just let you know, some of you don't know me yet. As Nancy mentioned, I've been around NCSA for a long, long time, had a long history here, actually a quarter of a century, if it makes me feel old. But I'm also now the humanities specialist for XSEDE. I've been in that role for about 6 months now, and I also work with a group called ICHAS, which is the Institute for Computing in Humanities, Arts, and Social Science. And I've been with them since they were founded several years ago, where we've been working with digital humanities, working with humanities researchers who are interested in using not just high-performance computing as in supercomputers, but any kind of technology. So that gave me a lot of experience in working with researchers, and then extending that on into high-performance computing space seemed like a natural fit with my experience from NCSA. So so that people know what I'm about outside of that and the kinds of things I work on in ICHAS as well, and what over at NCSA. For a long time, I've been doing scientific visualization work, other kinds of visualization. I've done a lot of work in virtual reality with the CAVE systems and the head-mounted display systems, with augmented reality, where we're mixing digital information in the real world registered in geographic space. And I've also been working with the idea of empowering the general public with the ability to take digital information and manufacture that into physical objects through personal fabrication. So basically, aside from the sorts of things I'm doing with XSEDE, those are the kinds of areas I'm in that really fall into the area of human-computer interaction overall. So, when Nancy asked me to give this talk, she asked me to talk about some of the projects that are going on XSEDE from the humanities, and I will do that. But what I thought might be helpful, too, rather than just list a bunch of projects, would be to sort of extract some of my thoughts and observations from my first 6 months with XSEDE, and they're colored by my experience prior to that from NCSA and ICHAS. But I just wanted, before I became involved with XSEDE, there were already some humanities projects on XSEDE, not too many. We're growing that number. As I'm going around talking with lots of researchers and research groups, there's a lot of people who have this in the back of their mind, but just haven't taken the leap yet. So I think that having this position in XSEDE is hopefully building bridges to allow those people who have ideas in this space to realize that it's not as daunting as it might appear, and that there's help out there, that the XSEDE people can help with their projects. I meet with people who say there's no reason for HPC in the humanities, and I think some of those people may come around, they may not, but a lot of people are saying, no, those people are incorrect. We need high-performance computing, we need new technologies, we need new methodologies for doing humanities research, because As data sets get bigger, as problems get bigger, the idea of the lone researcher sitting in his office writing books with a pencil is kind of gone now. That the future, if the humanities are to have an impact on the world, and we believe they can, it requires much larger efforts where we're looking at not just one piece of data in isolation, but seeing how that fits in a more global picture, and be able to make some predictions that are backed by science, to be able to allow the researchers to be guided in their own research with computer assistance. So I think asking, what are humanities researchers doing and what are they interested in doing is like saying, what is a scientist interested in? It's all over the board, and people have different areas of interest, different methodologies they use, and different topics they focus on. As I go around meeting with groups, just a little bit more history of me at NCSA. I was the original training and outreach director at NCSA. So I flew around the country giving talks to scientists and to engineers, telling them about the resources available through NCSA. And actually, a lot of the conversations I'm having in the humanities groups is similar in many ways, because they're asking some of the same questions, and I've got a slide about that coming up here, asking the same kinds of questions that scientists were asking back then. And not everyone thought that high-performance computing was beneficial to science. Just one quick anecdote. In the early days, I was out and traveled to one of our industrial partner sites, and we were talking about computational chemistry and the idea of using simulations on supercomputers as a supplement to the bench work in chemistry. And I was along with a computational chemist, and our host that had us in this company said, I want to take you to my boss's office so that we can talk. And we got to the office, and it was one of those doors that had a big window in it, but the window was covered with a poster, and what the poster said was, real chemists don't use computers, right? So in many ways, this last, the bullet that says there's no need for HPC in humanities is similar to what I saw then, and we all know how that's changed over the past 20-some years. Right, you're all virtual. Oh, by the way, there's 5 of us in the room here from NCSA. So some of the questions that people are struggling with in the humanities who are interested in doing this are the same kinds of questions that scientists were and still are asking, I think. One of them is it really research? Is it real research? Because it's a new methodology. It's breaking from how we've always done things. And so I don't even know what I would do with the big computers. It won't count for promotion and tenure. I remember hearing that from the scientist. Sudhakar, that's gone now, right?
Hopefully that's gone.
Right. So that's been changed in the science spaces. But again, they're questioning. They say, well, I'm really interested in doing this. I think it could be very helpful to my research, but my committees, my tenure committee doesn't see this as valid. So these are some of the challenges that people are running into. Other challenges are with respect to methodology. I hear back from people when we talk about what it would mean to do some of their research on the big machines, the typical batch-oriented workflow, they're like, well, why do we have to do that? That's not how we work. And a typical response, the quick response would be, well, that's how it works on a supercomputer. But we're trying to find ways, how can we meet in the middle? How can we do things that support their current methods and workflows? And indeed, I'll talk about one project later on where we are doing something with a real-time, on-demand kind of workflow as opposed to a pure batch-oriented. Some of the people that I meet, I say there's people available to help, through the extended consulting services and things like that. And people are frightened of even talking with the people in the supercomputer centers. I put the GASP on there. It's a very real perception out there. But I do want to tell you an anecdote. a couple of years ago, this is before I was involved with XSEDE, through ICHAS, but in cooperation with NCSA Pittsburgh Supercomputer Center and San Diego Supercomputer Center, we won a small NEH grant to expose some research groups from the humanities to high-performance computing. And as part of that, we took 3 different research groups to visit Pittsburgh Supercomputer Center, San Diego Supercomputer Center, and NCSA. And I went along with each of these groups to each of these sites just so I could observe and see what was happening. And one of the things that I was told over and over from these research groups after we visited the centers was, wow, those people weren't what I thought they would be like. And I said, okay, what's that mean? And they said, the people we met at the supercomputers seemed like genuinely nice, normal, decent people that we'd like to work with. And I think that shows something about it's a perceptual issue, a perceptual disconnect, not a totally real disconnect. Now, there are some disconnects that are genuinely real, that you meet certain people, and there certainly is a breakdown in, if not the person they would necessarily choose to have on their project team. But I think they were surprised and delighted to see that the people were genuinely interested in their work and wanted to help them do their work, and that they were people they got along with and wanted to work with. And then finally, will it be accepted by my peers? That falls in with this whole promotion and tenure thing of whether these are real. So some of the general categories of applications that I've been seeing fall into these categories. One of the biggies is text analysis, and there's, of course, many, many different kinds of text analysis you can do, and I'll talk about some of those when I mention some of the projects. Basically, topic modeling, data mining of different types, genre classification, so different kinds of classification projects, those sorts of things. Image analysis, where people are looking at maps or photographs or artworks or different sorts of imagery, scanned documents that aren't necessarily OCR'd. There's all sorts of challenges with images in the humanities because they often use ancient scripts, ancient languages, those sorts of things. Those are all big challenges. I'll talk a little bit more in depth about a video analysis project that I'm directly involved with. A lot of projects in doing network analysis, simulations, and simulations, again, are all over the board. Some of them are very akin to scientific simulations. So if someone's looking at how ideas diffuse through populations, is it reasonable to look at diffusion models like a chemist might look at of diffusion in a solution, things like that, to be able to predict how different things will propagate through society. Of course, there's a lot of GIS and mapping types of applications, and then some of the projects are interested not so much for the computational side, but also just for the visualization side and what they can learn from looking at their data in new ways. I pulled this image out of Bruno Latour's paper. I chose it just as not about a specific thing, but just to say that in my experience, lots of times we're talking about the same things, but people just think about them differently. The humanities researchers versus the more technical researchers. This particular image I pulled out of this paper, I don't know if you can read it. It says, out of the one face, it says, once the machine works, people will be convinced. And out of the other face, it says, the machine will work when all the relevant people are convinced. So sometimes we just think around the same issues from a different perspective. That was my point in including this picture in this talk. And so that's something we want to be cognizant of and not force these new communities into our way of thinking and not let them force us into their way of thinking necessarily, but what we can learn from each other and how we can work together to solve some problems that are interesting to all of us. So I've noted that of the people I talk with, there's basically 4 groups of people. There's those that have code. Usually they have expertise. They know what they want to do. They're just like, give me the machine and let us go. Those are pretty far and few between, but they do exist. Another big one is people who are using third-party codes that may or may not be on the big HPC machines. So, for example, I get people that are using MATLAB and things like that, which is available on the Pittsburgh machine, but other codes, other application codes that may not be available. And then so the dilemma is, do we try to get those applications up on the big machines, or do we find some substitute that can go up on the machine? Do we write our own code, or do we say we just can't do this? So the third bullet is the one that I worry about. People who have no code, but they have a great idea. And so this is one of the gaps for humanities computing on high performance on XSEDE, is where does application development happen? We know that there's extended consulting, but that's not to sit down and develop new codes based on my understanding. So somehow we need to fill that gap of if someone's got a great idea, they want to model something or do some new kind of analysis, but there's just no code, what do we do with them? And I hate to tell them, well, there's really nothing we can do until you've got something. We could do this and this and this and this, but if they're not interested in those things, they kind of just have to go away, at least for now. Then there's other people who really have no idea what to do, but they're really interested and they think there must be some way these tools can help them. And that's where I'm trying to help by showing some of the different kinds of things that can be done. Just, this is a random list I made up last night of just the things that popped to mind of the most often things that people have mentioned as I've been talking to them in terms of code. These are in no particular order, but there's database problems. People are using things like MySQL. There's a startling amount of Python sort of hackers in the humanities communities. MATLAB, this NetLogo is something that I wasn't familiar with, but I heard it coming up and in a couple of projects, and I know that NetLogo is implemented now on Blacklight at TSC. So I just thought you might be interested to see some of those kinds of things people refer to are the statistical package. Having conversations with folks from the humanities research groups, it's clearly a language gap between what is inside XSEDE and what is in the humanities research. Even the words, there's many words that are used in common, but they mean different things. At the highest level, they mean the same thing. But for example, in a conversation about data, I might say, well, do you have data? Oh, yes, we've got a lot of data. Oh, you've got a lot of data? How much data have you got? Oh, we must have half a warehouse full. There's probably 400 boxes in there. Boxes of what? Newspaper clippings. That's what we've got. So that's a big gap in terms of we need to make sure we're talking about the same things at the same time. The word model means different things, of course, even within the scientific communities and simulation, those sorts of things. The humanities researchers have very different expectations. I'm generalizing here. Very much so the black and white answers, or at least how they consider scientists have black and white answers, whereas they have gray, fuzzy answers. And when I talk to them about different jobs that could be run on the machine, they'll describe a scenario and I'll say, well, how do we know when we're done as we're going through and doing this analysis? And they'll say, oh, I know I'll know it when it's done. I said, well, how will the machine know when it's done? And they said, well, it'll ask me. And that's a reasonable thing, I think. But I say, well, would I know when it's done? No. So it's this back and forth dialogue of how people think about their work, how they interact with their data, how they interact with their ideas. And I'm constantly caught in this chasm where it's this dilemma of trying to fit the researcher to the system versus making the system work for the researcher as well. A lot of scientific users have adopted the typical workflow of the high-performance computing arena, because that's how they've always done it, and that may or may not be the best way to be moving forward. But they've fit into that model. And so here with new users, I think it's time to raise the question of, well, if they're saying that's not a model that fits, do we try to fit them into that model, or how can we modify the model to allow them to work in new ways, which can lead to new ways for scientists and engineers as well to work. One of the things that comes up in those discussions a lot is the whole batch versus real-time on-demand interactive sort of things, and I'll talk about that with the project coming up here shortly. Some of the big technical hurdles are the digitization problem. There don't seem to be funding RFPs for digitizing materials. So again, that's one of those gaps where people say, oh, this is exactly what we want to do. We even have code to do it, but what's getting in our way is we need to get our data in a digital format. And so that is one of the gaps here, is the lack of the digitization capability. I mentioned already the application development. And this is interesting too, is I think when they are talking with me and talking with XSEDE folks, they're recognized, okay, this means I am going to be working as a team as opposed to a lone researcher. And that's new sort of to many of the researchers I encounter. Okay, so just to jump to some of the current and proposed projects, I know I'm running short on time here. This one is one that I was a co-PI on before I even was with XSEDE. This is a large, I'm very familiar with this project, so I'm going to zoom in on it a bit. The question is, that's being posed by researcher Virginia Kuhn out at USC. She's from the media literacy, the Center for Media Literacy, and other people involved on that project are Ritu Arora from TAC, and Dave Bach here is doing the visualization, and there's several others involved in this project. So what we're doing is looking at these huge collections of video. And the question is, how can you do research on that when there's more video being generated at any given moment than all the people on the planet, if they were watching it together, could watch, right? We've got not only videos that are purpose-made, but there's surveillance video, all these sorts of things. So what we're looking at is how can we use high-performance computing to analyze that data? And from the researcher's perspective, from Virginia's, who's the PI on the project, she's interested in asking questions like, how are women portrayed in film? And so what that might lead to is she might want to ask a question of a huge archive of film and say, I need to see all the shots where there's a woman being portrayed in the scene, and I want to see all the shots where they're portrayed with the camera facing down on them versus the camera facing up, or any number of different types of intellectual questions that she wants to ask. This has led to all sorts of technological development, and basically what we're trying to do is build a real-time, on-demand, interactive scenario where researchers can pose those kinds of questions and automatically extract metadata, but also to ask on-the-fly questions that couldn't have been predicted by a priori metadata extraction. So what we're doing, we've got a system where we've got interactive access on the I/O nodes on Gordon, tied in through a user interface, which we're working with the Medici development team to use this as the interface in the system. Dave Bach has been doing some amazing visualizations. This is one example down here in the center of the bottom of it, where the video frames were stacked up into a cube, and then you can slice and dice that cube in many different ways, and immediately you can see as the cube is progressing back in time, I think it becomes very obvious. You can see where the scene changes are on that cube. And Dave has a term for this. What's the term?
Movie cube.
No, not movie cube, your other...
Temporal simultaneity.
Temporal simultaneity. So the idea is to be able to see a lot of time all at once. And to look at films, and you can see a lot of different visualization ideas that he's experimenting with here. We're working with Harriet Green on a project, and I figured I'd run out of time here, so I took some of her words exactly and put them on the slide so that people could look at these at their own leisure. I think Harriet's on the call here, but at the core of it, they're looking at some really innovative and unique recommending systems for libraries, for knowing how to recommend materials, how to purchase materials that will be useful. Also, they need to be able to model patron behavior, those sorts of things. We're working with Ted Underwood, who has 500,000 texts from the Hathi Trust, and he's working with machine learning to do genre classification automatically. He's also doing various types of topic modeling, where topic modeling is basically clustering around topics. You're looking at co-occurrences of word groups so that you can pull out the main topics and ideas from huge corpuses of information. Vernon Burton is looking at 2 billion pages of 19th and 20th century historical materials. They're looking at Civil War information and looking at emotional, thematic, and geographic analysis of those collections. Over at Indiana University, Beth Plale is, they're stewards of the Hathi Trust, so they're exploring a number of different ways to analyze those texts. And they also are teaching through this UNCamp for Digital Humanities with using the Hathi Trust thing. We're working with Michael Regenwetter, who's comparing different models of decision making. There's all these different algorithms of different ideas of how people make decisions. I call it the decision making bake-off, but I think he's got better terms for it than that, where they're comparing different models and algorithms for how people make decisions. Some of the proposed projects is with the Abraham Lincoln Library. They've got a lot of scans that they need storage allocations for, but also automated processing for analysis and for automatic cropping of them and for doing visualization about what the contents of those. And another proposed project coming up is Graham Sack at Columbia University, where what he's doing is tracing the evolution of literary genres and also being able to predict and steer future evolution of those. And so with that, it's 1 o'clock. Bing, I guess that's it.
Alan, thank you very much for a fascinating talk. I believe there's another group that uses this telecon number immediately after the symposium, but do we have one question for Alan from the group? I thought it was a very, very nice presentation of what the challenges are and nice categorization for a lot of us who aren't used to thinking in this regard about, what types of analysis are typical and what different stages the researchers are at. So this was very enlightening for me, and I hope others as well. People can contact Alan's contact information is on the symposium website. So if you want to talk to him about projects that you see at your own institution afterwards, you'll be able to find him there, and the slides from both speakers will be up. So thank you very much. Next month, we're going to skip the symposium. It occurs during Thanksgiving week, and a number of people are off on vacation or recovering from supercomputing that week. So we'll pick up again in December. We have some speakers lined up at that time. So thank you very much. Bye.